Question 18a. Unpolarized light of intensity I naught is initially incident on polarizer A, which polarizes light in a vertical direction. The polarized light then falls upon polarizer B, which is aligned such that it has a polarizing angle of 60° with respect to the vertical. What is the intensity of light after passing through first polarizer A and then polarizer B? So here you have an unpolarized light that has intensity I naught, and it first passes through polarizer A, which is aligned vertically. So when the light passes through this polarizer, only the vibrations which are parallel to the vertical axis will pass through, and all of the horizontal vibrations will be blocked. So light intensity coming out of polarizer A, which we can write as IA, will be half of the original value because all of the horizontal vibrations are blocked and only vertically aligned vibrations can pass through. So the intensity becomes half. Then this vertically aligned vibrations is now passed through polarizer B, which is at an angle of theta equals 60° with the vertical. So now we use Malu's law to calculate the intensity. I write IB to be equal to IA cosine squared theta. IA here is I naught by 2 cosine squared 60. Now cosine 60 is half, and when you take square of half, it becomes 1 by 4. So the intensity of light coming out of polarizer B will be I naught by 8. Next, we have a similar question, but now instead of polarizer B being at 60°, it is at 30°. So we do similar calculation to get intensity through polarizer A and B. Again, this is an unpolarized light, so its intensity is I naught in the beginning. When it passes through polarizer A, which is vertically aligned, only half of the light can pass through, so the intensity becomes half of the original. So we write IA is I naught by 2 because it will only allow vertical vibration and block all the horizontal vibrations here. So the light coming out of polarizer A is now vertically aligned. We call this IA, which is now incident on polarizer B. So intensity of light coming out of B can be written as IA cosine square theta. We will use Malu's law to calculate this. So IA is I naught by 2 cosine squared 30. So that gives you I naught by 2. Cosine 30 is root 3 by 2. When you take square of that, it becomes 3 by 4. So IB will be equal to 3 I naught by 8. Next, we have question 18c. Here in both figure A and B, the light has initial intensity I naught. So intensity of light here is I naught, as well as here also it is I naught. In which situation will the intensity of light after passing through polarizer B be the greatest? Explain your reasoning. So let us calculate the intensity of light coming out of polarizer B in both cases and then compare them. So here I have an unpolarized light of intensity I naught. I know when it passes through polarizer A, which is aligned vertically, its intensity here will become I naught by 2 because only half of the vibrations will be allowed to pass through. The other half, which is horizontally aligned, will be blocked. Then this light falls on polarizer B, and now I have to use Malu's law to calculate its intensity because now this is plain polarized light. So I get light coming out of polarizer B to be equal to I naught by 2 cosine square 60. That gives you the value of IB to be I naught by 8. Now we do the same thing for figure B. The difference here is we have a plain polarized light of intensity I naught instead of an unpolarized light. And this light is polarized in vertical direction. So when it passes through polarizer A, all of the light will be able to pass through it as it is vertically aligned. Polarizer A is also vertically aligned, so it doesn't block any light. It lets all of the light to pass through. So intensity coming out of A will be equal to I naught and not I naught by 2. You can also apply Malu's law to check this. Because this is a plane polarized light, and when I apply Malu's law, I get IA to be I naught cosine square theta. Theta over here is 0 because both of them are in the same direction. So you get I naught cosine square 0. Cosine 0 is 1, so intensity coming out of A is I naught. So anytime you have a plane polarized light in the beginning, you have to use Malu's law to calculate its intensity. Then this light IA is now passing through polarizer B. So we find its intensity using Malu's law again. IB will be IA cosine square theta. IA is just I naught cosine square 60. So IB becomes I naught by 4. Now when you compare the two, you will notice that in case B, intensity of light coming out of polarizer B is greatest. So I can say that in case B or figure B, the intensity coming out of polarizer B is greatest. And that's because in the beginning, here we had a plane polarized light which was passing through polarizer A having the same axis of polarization. So none of the light was blocked. All of the light of intensity I naught was passed through A. Whereas in the first situation, in case A, we had unpolarized light of intensity I naught. So when it was incident on polarizer A, only half the vibration could pass through and its intensity became half. This is why intensity of light through polarizer B is greater in figure B. Next question. Here they are asking you what would happen to the intensity of light after passing through polarizer B if the angle of polarization was first increased and then reduced. Explain your reasoning. Now, when the unpolarized light of intensity I naught passes through polarizer A, which is vertically aligned, only half the vibrations can pass through. And I can say the intensity of light coming out of A is half the original value. Then this light is incident on polarizer B, which may have a polarizing angle theta with respect to vertical, and we find its intensity using Malu's law. So I write IB to be equal to IA cosine square theta. So basically the intensity of light coming out of polarizer B is directly proportional to square of cosine theta or square of the angle of polarization. Now cosine theta increases if the value of theta is small. That means when theta is 0, cosine 0 is equal to 1. Whereas when theta becomes 90, cosine 90 is 0. So cosine theta will increase the smaller the value of theta is. And cosine theta will decrease the larger the value of theta is. So when we increase the angle of polarization, cosine theta reduces. And if cosine theta reduces, the intensity will also decrease. Whereas if you decrease the angle of polarization, cosine theta value increases. And if cosine theta increases, intensity will also increase. Therefore, as we increase the angle of polarization, the intensity coming out of polarizer B will decrease. And as you reduce the angle of polarization, intensity of light coming out of polarizer B will increase.